Hi, moving on to question 10. This is the first part of the higher tier part of the paper, so the difficulty will immediately ramp up from here onwards. So this question here is a question of ratio in triangles. If you know your triangles and you know your ratio, this is not too bad, but you are expected to use them in tandem here. So notoriously, the angles in a triangle add to 180. So first of all, let's work this out. So A plus B plus 25 equals 180. So minusing 25 on both sides, we make the deduction that A plus B is equal to 155 degrees. So we know that A and B are 155 in total, and we know that they are in 5 parts. So the ratio of A to B is 2 to 3. So there are 5 parts in total, and they add to 155. So the calculation we do is 155 divided by 5. So I'm going to do this up here. So 5, and then in my bus stop, how many 5s in 1? 0. How many 5s in 15? 3. How many 5s in 5? 1. So it is 31. Each of these pieces is worth 31. So now A gets 2 parts and B gets 3. So A is 31 times 2, which is 62, and B equals 31 times 3, which is 93. So I know these are correct because they add back up to 155. So A is 62 degrees and B is 93 degrees, which is quite a nice question, I think. So question 11a, find the lowest common multiple of 60 and 72. So immediately my thought here is to use index form and use a Venn diagram, or use any particular method using index form to find the LCM. But I also noticed that this is worth 2 marks. So as a mathematician, I know that 60 and 72 divide 360. So I know that their LCM is 360. But that is not realistic for a GCSE student to know immediately. So what I'm thinking here is, because this is 2 marks, we should use the overtake method. So firstly, the LCM of 2 numbers is simply where their times tables meet. So allow me to give you an example. We're going to look at the LCM of 3 and 5. So essentially, where do their times tables meet for the first time? So 3 and 5. So which one's lower? It is 6. So now 5 is lower, so we get another one in this times table. Which one is lower? It is 6, so we get another one. Which one is lower? Still this one. Now which one's lower? It is this one. No, it's this one that's lower. And we have a match. So the LCM is 15. And we're going to do something similar for 60 and 72. So 60, 72, so 60 is lower, so the next one in that times table is 120. Now 72 is lower, so that would be 144. Now 120 is lower, so it's 180. And now this would be 216. On the next one here, this would be 180, so this would be 240. So the next one now, we add 72, so that's going to be 882. So that's going to be 288. And now let's add 300. It's lower. And now this one is lower, so it is 288 plus 72. So I believe that to be 360. And now this one is also 360. So we have a match here. So the LCM of these two, as I said, is 360. Okay, last question. So part B, express 882 as a product of its prime factors. You are required to give your answer in index form. So as I've mentioned before on this channel, we want to look at a number and deduce numbers that divide it. So because this ends in a 2, we know it divides 2. And it's quite a nice one. So it's 2 and 441. We circle 2 because it's prime. So splitting 441. So I'm going to do this a practical way first of all, and then I'm going to do this the realistic way. So we can actually just do the realistic way. So I've taught a number of methods on checking for divisibility, and one of them is checking for divisibility by 3. So if a number divides 3, its digits add up to a number that is in the 3 times table. So 4 plus 4 plus 1 is 9, so that means that this number divides 3. The practical way I would do this normally is, because I'm a mathematician, I know this is 21 times 21. I know it is. and then I would split each of those into 7 and 3. But let's be practical, that's not a very well-known fact. So let's split this into 3 and something else. So this would be 3, and we need to work out what it splits into. So let's do the bus stop. How many 3s in 4? 1 with 1 left over. How many 3s in 14? That is 4. 2 left over. How many 3s in 21? That is 7. So that is 147. Once again, let's look for stuff that it divides. So what do its digits add up to? Its digits add up to 12, so it divides 3. So let's do 3 again. So 147 this time, divided by 3. How many 3s in 1? 0. How many 3s in 14? 4 with 2 left over. How many 3s in 27? 49. And then 49 is notoriously 7 squared, so that's 7 times 7. So 882 in index form, and we have to do these in ascending order for base numbers. So it is 23377. 2 times 3 squared times 7 squared